All right, so let's get back into this. Let's go ahead and create a new variable. Let's say float. So what floating is, it's a floating number. And what that implies is that it's up to a 32-bit precision. So if I wanted to do a new number, so decimal num, sorry, bad form. And then we can say, 3.6 or 2.89, something like that, right? This is saying with float, we can have up to 32 bits following the period of accuracy for that floating number, but you need to put an F at the end of it, allowing it to be float. So if I were to then sys out control space and then do decimal num, go ahead and save and run that, you're going to see 2.89. So it did actually work. It kept all of the numbers following the period. But it's just not always your best move. And I think if you're worried about space allocation or you don't care about a certain number of decimal values following the period, I really wouldn't use float. A lot of the times it's more easier to just use a double. So double is going to say I want 64-bit as opposed to 32-bit precision. So we don't even need the F when we do a double. And it'll still work in the same way. We run this again, we see 2.89. So that is the difference. And we can actually say decimal num equals decimal num plus number var. So what is this actually doing? Remember, you always want to finish with a semicolon. So what this is saying is take whatever is stored in decimal num, add it to number var, and then store these two values into decimal num again. And it won't overwrite this here, it'll overwrite it here. So anywhere that you use it after this below, it's going to have that same new value that you put in here. You won't be able to reference the original decimal num value unless you resubtract this number var. So this is overwriting. It's done for efficiency purposes and sakes where you don't need the original number again, but a lot of the times people will often create another variable, saying like double stored val or something like that, right? I don't even need to declare a value following that. And we can just say, stored val, equals that. And then I can also show you with that same decimal num equals, I'll just copy this, paste that here. So now we have the same thing twice, right? This is literally saying take decimal num plus number var and store it into stored value. And this is saying take decimal num plus number var and store it into decimal num. So if we actually sys out here, control space, and we do stored val, and then, it'll actually print that out. And then if I do sys out, yep. And just to show you guys, well, here, I guess we'll do decimal num, right? So this shouldn't have changed at this point. This should still be 2.89. And this will print on this new line. So, but I wanted to prove also that, I wanted to show you guys the case of where you try to concatenate a string to this. So if I were to write stored value is, and then concatenate. So what you would think what this would do is write the word stored value is, and then a space, and then a added on that. But let's see. It actually did. So it did concatenate between string and integer, which is, or string and double. Now, why there's a 0.00001 there, I'm not entirely sure, but we can figure that out. It might have to do with something when you add between a integer and a double, but in any case, it did actually do that, and then we could sys out decimal num, and decimal num was 2.89, and then down here you see that decimal num is 4.89 because of that second operation that happened. So decimal num is, right, so we run that. So decimal num was that, and then decimal num after overwriting. There we go. Sorry, I'm having a bad moment there. So just to see it more clearly, you see that this is what it was. We did these operations here, and then we decided to overwrite these into decimal num, and you see that it's overwritten here. So you'll never have the same 2.89 unless you subtract out again that original value. So I think this will be where we wrap up this video, and we'll jump into strings and characters on the next one.